Hello, this is Mr. Coates, and this is APES lecture number 44, the Introduction to Global Climate Change. Now I'm going to be the first to admit that I don't know everything about climate change. I know some of the basics, I know how it's supposed to work. The problem is getting all the data together and looking at the data and knowing if the data is correct or knowing if something's done with the data is just really hard, and there's a lot of problems going on with the global climate change and global warming debate, and a lot of the problem revolves around all these jokers. This guy here, this one here, this senator down here is famous anti-global warming. This local DJ, he's got a whole website devoted to climate change. This guy, former Vice President, won a Nobel Peace Prize because of his ideas on climate change. And then, of course, this bag of hot air over here. These guys, they just constantly talk and voice their opinions, and none of them are scientists, but yet a majority of the people out there take their cues from all of these guys. And the problem is that this just creates a lot of noise out there. Noise, noise, noise. In fact, even this guy down here, some of the stuff he spews might be noise too. But the issue is there's just too much noise right now, and it's really hard to figure out exactly what is the real story with global climate change. Like I said, I'll be the first one to tell you that I don't understand it all. What I can understand is graphs. So I'm going to present some graphs, I'm going to present some other data, and I can understand those things. Now, is the data that the graph's based on good data? It's hard to say. Once again, there's lots of arguments out there whether or not the data used in the climate change debate is worthwhile. So let's take a look at one of the first graphs. This is the graph you see quite a lot, and it says it's the global mean temperature over land and ocean January through December from 1880 all the way to 2000, and I think it's 10 in this one. But basically it shows, if you look at the mean average temperatures over the entire globe, it's an increasing trend, especially later on after 1960s, 1950s. So this is something I can understand. It looks like the globe is warming up, and so I can get on board with there's actually warming happening. The problem is that why is it happening? And that's the part that I think needs to be more of a discussion than is it happening. These guys over here, like this one right here, him saying that it's not happening at all, I think he's an ostrich with his head in the sand. But these guys down here are the other guys that we looked at. Those all guys saying that we're all going to die because of it, I think they're alarmist. And so there needs to be a happy medium somewhere, and I don't know exactly where that is. But we'll see if we can maybe figure out some of it as we go. So the first thing I want to get across is that there's a huge problem out there with getting climate and weather confused. The press is really bad at this. The press, if you look at all these little cartoons that I picked out here, you got a snowstorm with a bus in it, and you have this church of global warming on the side of the bus. You got another one here, it's about the same thing. It's snowing, therefore the global warming's a hoax. Another one here, it's hot and it got hotter, and so this is 1 day's worth of data here. Fox News is really great at this kind of stuff. Once again, saying one event disproves global warming. Here's another one, even a decade. They're using an entire decade here, and they're using that to tell about all these deaths. And a decade's not even enough data to even say the climate's changing. So the problem is that there's a lot of confusion as to what the difference is between weather and climate. And so we have to make sure that we know that climate is a long-term average. We're talking maybe even hundreds of years worth of data, at least more than a decade anyway, and it's an average. Where weather is a single daily event. If you have rain, then that's weather. If you have snow, that's weather. I mean, you have one hot day, that's weather. You have a hot summer, and that's just weather. That's not an indication of any kind of climate change whatsoever. And once again, all these people make that huge mistake, and you see it almost daily on the news. Here's another one. Some representative from Louisiana, during the president's inauguration speech, he mentioned something about global climate change. Well, he gets voted in November, and he gets inaugurated in January. I mean, can you imagine him wearing anything else in January than a trench coat in Washington, D.C.? It's cold there. I mean, give me a break. And then adding this comment is just ridiculous. And so all this noise that I've been talking about goes into this whole confusion of climate versus weather. Now, the other thing about this is that we have to understand the greenhouse effect. The greenhouse effect is a natural phenomenon, and we need it in order to stay alive on the planet. Without the greenhouse effect, the planet would just be a lifeless ball of ice out in space. We need the greenhouse effect to stay warm and have a decent temperature for life on the planet. Now, the way the greenhouse effect works is that there are types of gases in our atmosphere, and these gases trap heat, and I'll explain how this happens in a moment. But some of the most important gases out there, water vapor and carbon dioxide, these are the most abundant ones that are out there in our atmosphere that actually act as part of our greenhouse effect. And then methane's another one, ozone is another one, nitrous oxide, and CFCs are chlorofluorocarbons. And we'll talk about those more when we get to ozone. These gases all work together to produce our natural greenhouse effect. So the way the greenhouse effect works is that you have photo radiation, so light radiation that comes in from the sun, UV light, visible light, and so that comes in from the sun. So as this sunlight comes in through our atmosphere, it can do a couple things. It can bounce off clouds and back out into space. It could also bounce off the Earth's surface, like ice areas or water areas, and bounce back into space. And so this stuff that bounces back does not create the heating. However, when the Earth absorbs some of this light energy, or clouds absorb some of this light energy, or even the gas particles within the atmosphere absorb some of this energy, it turns it into infrared radiation, which is heat. And so what happens is that as this infrared radiation comes back from the planet, layers of gases stop this infrared radiation from leaving the planet. Now, too much of gases, scientists say, that will increase the warming effect. Too few gases, that will decrease the warming effect. Now, one of the most important agencies involved in this whole climate change debate is the IPCC. This is the Intergovernmental Panel on Climate Change. Now, this is a group that is made up of 195 United Nations members, and their job is to assess the current trends, data, news, research, whatever that's out there on climate change. They really don't make any policy. They're not true scientists, but basically they're a panel, and every year they make their annual report on climate change. And it talks about the year we had, and if it was warmer than all the other years we have measurements for. It talks about where the greenhouse gases came from. It talks about the newest science out there about how to deal with climate change. It talks about some of the ramifications of climate change. So this is a huge report, and if you want to read it, you can always find them online at ipcc.org. The IPCC basically gets all their information from thousands of scientists worldwide that give their information to the IPCC voluntarily. So the IPCC doesn't pay for any of this information. Now, all of their findings in this report are based on the data. Well, this report did say something very important. It said that there is a 90 to 99% probability that the lower atmosphere is in fact getting warmer. Well, that's the graph that I showed you earlier. Now, the other part that it says it's most likely caused by human activities. Now, this is where the smart debate in climate change comes in. If you're debating whether the globe's getting warmer enough, I think, once again, you're putting your head in the sand. But debating whether it's because of humans, that's the smart debate. And being able to prove and support that idea is a very difficult thing, and we'll get into that a little bit later. So what is global warming? Global warming is just the generalized warming of the Earth over time due to the greenhouse effect. And according to data, and it looks like the temperature has increased since the 1950s, mostly due probably from human activities. It's very hard to discount the effect of 7 billion people on the planet. And since the 1950s, we've increased our burning of fossil fuels, we've increased our agriculture, our deforestation, and the use of CFCs. And all these things contribute to more greenhouse gases in the atmosphere. We saw this graph earlier about our coal consumption, and China's coal consumption has gone through the roof, and because of all that, they're also emitting lots of CO2 out there. Now, the most significant gas produced was this CO2, but methane has also increased because of agriculture and feedlots that we talked about before, the amount of fertilizer put out there, as well as N2O. And so you can see by this graph the amount of fertilizer use in the world since the 50s has also increased heavily. and that might add to this N2O issue here. These are some of the things that they use to correlate the data. Once again, remember, correlation does not always mean causation. There is supposedly a scientific consensus. This means a majority of the climate scientists out there agree that the planet is warming. Now, a lot of them also agree that humans are the cause. The problem is agreeing exactly what to do about it and where the actual warming is coming from or going to. Also, looking at the data, global surface temperature worldwide increased 1.3 degrees Fahrenheit between 1906 and 2005. Now, that doesn't seem like a lot, but globally, this can have huge ramifications. And so, even though you don't see a huge temperature increase globally, we'll look at some of the ramifications of that a little bit later. Arctic temps. We've had Arctic temperature gauges up there for a long period of time, and Arctic temps have definitely increased twice as fast over the past 50 years. And this is mostly due to one thing that we've talked about earlier, the grasshopper effect. And then the melting of ice. This is something visual we can actually see. We can see ice disappear. We have pictures of what the ice looked like. We can compare it with pictures of today, and you can tell that it's disappearing. So this graph shows you that over the last 150 some years here, it looks like temperature has really increased because of that on a global scale. And once again, it's not that much. We're only talking about from like 14.8 degrees or 14.7 degrees Celsius down to about 13.7. That's 1 degree Celsius. So, I mean, that's not a whole lot. Once again, it can have some pretty good effects. All right, so how do we predict the future? Scientists use a lot of computer models. These are very complex mathematical models. They run on computers. They put in all kinds of data, reams and reams and reams of data that could be based on billions of data points and thousands or hundreds of parameters, CO2, methane, ocean currents, deforestation, cloud cover, ocean area, size of cities. All these things can be input into these models and used to predict what's the future going to be if CO2 keeps on increasing. The IPCC said most models project that it's very likely that 90 to 99% that human activity is the reason for the observed warming over the last 55 years. If you look at this graph, it's a graph that's created by some of the models, and it shows what our temperature has been. So this is the fluctuation of temperature since 1857. And it shows this general increase. Well, our models, when we input all the data, put the temperature within this cone of uncertainty. And it looks like right now that this temperature is following this. In fact, it's on the high side of the cone uncertainty. So right now it looks like some of our models might be correct. Other data about if our models are correct or not come from some events that have happened on the planet. One of the biggest was Mount Pinatubo. In 1991, Mount Pinatubo blew in the Philippines. And some well-known climate scientists and NASA predicted that because of the gases and the ash released into the atmosphere that the globe would cool a little bit for a couple of years, and because it would be blocking sunlight. And so they fed all this into the models, and sure enough it predicted that the cooling, and sure enough over the course of about 4 or 5 years the Earth did cool as the models had predicted, and then the planet warmed back up just as the models predicted. So based on one of these events, it showed that the models were fairly accurate. Now once again, the models all depend on data, and you know what they say about data, garbage in equals garbage out. So you got to really ground truth that data, and you have to have really good data in order for the models to give you good results. And that's one of the crux with climate change. Is the data good or not? Well, I hope you learned something about climate change and some of the issues with climate change. We're going to get deeper into this subject as we go. If you have any questions, please bring them into class.